So speaking of things that didn't follow a perfect theory and model, JavaScript. So there's two things. One, it had an impact on the world at a huge scale, obviously, and it's also still is one of probably the most popular programming language in the world. So can we go back to the origin story? Can you tell the story of how JavaScript was created?
Yeah, I was at Silicon Graphics after graduate school for 7 years, and it got to be big and successful and divisionalized and political. And I thought kind of boring. And a friend who'd been there went to one of the last of the super companies, the super startups in the early 90s. There were several. I suppose General Magic was a little after that or around the same time. But MicroUnity was that company that I went to. And it was because my friend, Jeff Weinstein, had gone there from Silicon Graphics. He recruited me. And MicroUnity was doing everything. So this was like the ultimate sort of pretend grad school. It was doing a new fab, new semiconductor process. It was doing new analog and digital circuits on the same very large but not wafer scale chip. Originally, it was 5 centimeters on a side. It was really hot too, so it needed a water cooler. It was a Cray killer, and then they shrunk it and they tried to do a home sort of media processor that was essentially a barrel processor, but you could think of trying to do all the things that we now see in modern architectures with short vector instructions and sort of wide instructions or multiple issue, and doing a lot of the stuff in software, because the second iteration, the set-top box, was really for avoiding the cost to the cable company of rolling the trucks out to replace your garbage General Atlantic set-top box with a slightly newer, less garbagey one. So if you could have software upgradable set-top boxes, the cable companies thought they could save a lot of money and add features.
Is this assembly? Or which level of the software?
It was like we were writing we were using GCC, we were writing C++ and C. Somebody I worked with there, really very smart guy, hired from a sort of Wall Street hotshot programming consultancy, did his own hardware design as well as software. And we were working on how to make not only short vector units, but general bit shufflers and permuters, so you could do things like crypto algorithms efficiently, and you could do demodulation of the cable, complex quadrature amplitude modulated signal. So you were basically taking A to D converters, dumping things in buffers, and then doing the rest in software. All the framing and the Reed-Solomon and Viterbi and all that error correction. So that was really great learning experience, but it was not going to work. It was doing too many risky things at once, right? As Jim Clark said to me when I hopped to Netscape after 3 years at MicroUnity, he said, "Oh yeah, you do 10 things each, 1 in 10 odds. It's going to be 1 in 10 billion, right?" Yeah. The multiplication principle. So, Netscape was already a rocket, and I'd passed the chance to go there in 1994. I knew the founders because I worked at SGI, Clark's company.
Could you pause for a second? In Netscape, when was the launch of this rocket?
94.
94 was the launch of Netscape?
And I went there in early 95 in April.
Okay. But so you said you missed the launch.
Well, I missed the first floor employment opportunity, but the IPO was August 1995. So I was there for that.
How obvious was it that Netscape was like world changing? What was the layout? Was Netscape one of the first big browsers?
Yes. So when I was at MicroUnity still in 93, we saw a browser called Mosaic. And up till then, we'd used email and we'd used Usenet, the NNTP protocol. We'd used newsreaders. We used FTP. We used all these old internet protocols, all relying on the DNS and TCP/IP and UDP for that matter. When I was at Silicon Graphics, we brought up the whole stack, right? We had to, discover how to find the Ethernet addresses on your network and then find IP addresses for them, ARP protocol, all that stuff. And it was great because nobody knew in the 80s what was going to win. All the proprietary stacks like IBM, SNA, and DECnet, and all these other protocols were saying we're going to do it, or it's going to be heterogeneous future. And instead, it was Berkeley Unix and the TCP/IP stack that dated back to the ARPANET that won. And I think we knew it. We all knew it at SGI, but the salespeople didn't. And so they kept trying to get multiple network stacks interoperating. But in the end, it won. And so that was the internet. And it was email and texty. And it was Usenet, very texty. And then Tim Berners-Lee did his thing, but I don't think I was paying attention. And I think the date when he first did it, or when he wrote the famous email, has been pushed back to 89. But I noticed Mosaic in 93 because one of the things that Mark Andreessen and Eric Bina did at NCSA was they innovated on the early HTML standard. They, in particular, Mark sent this email saying, "Hey, everybody, we think you should be able to put an image in a page." And when he sent that, Eric Bina had already written the code. And I talked to Tim Berners-Lee more recently, just a few years ago, and he was like, "Oh, we had another way of doing it." And it didn't work out because Mark shipped his in Mosaic. And this convinced me of several things. One, the internet meant there was a huge first mover advantage, and being fast, getting on first mattered a lot. And so, Richard Gabriel of Scheme and Poetry fame has written about this, the famous essay.
What's poetry?
He's a poet.
Richard's actual poetry. Yeah, I thought you talking about some kind of something.
No. I mean, he's the founder of Lucid, which is where Jamie Zawinski worked before Netscape. And Lucid was doing, compilers, and Lucid Emacs, which was a fork of Emacs, famously Jamie fighting against Richard Stallman, Stallmax. And so Richard Gabriel, very, very brainy computer guy, but also a poet. But he wrote a nice essay that gets abused all the time. In fact, Jamie's put a kind of warning in front of his version of it on his site, jwc.org, called Worse is Better. And this is about survival advantage of software in the networked world, in my opinion. It's about Unix. It started out being framed as Unix and Lisp, good news, bad news, because all the Lisp people, the MIT people were like, this the crown jewel, right? Scheme, this Fabergé egg, or Common Lisp, this giant cathedral. Of course we're going to win. This is civilization. And those, those farmers in New Jersey, to borrow from the Sopranos, those hicks down at Bell Labs, they're just, there's nothing sound there. It's all hacking.
Yeah.
Well, guess what won?
Wow. So you're saying this is a fundamental principle of the internet is moving fast wins.
You could say in almost any network system, like in biological evolution, you see successful alleles sweep populations, and they don't always have, they aren't free of flaws. They heterozygous advantage, right? You can get both parents give you the gene variant, and you get sickle cell anemia, right? But if one of them does, you're more resistant to malaria. And so this isn't a beautiful process, except at large scale. And then you realize that because it moves fast and can adapt, it can win. And people still struggle with this. I used to struggle with this because JavaScript was done in such a hurry, and the force of web compatibility meant early mistakes couldn't be fixed. And even the standards process injected new mistakes, as it will. But often standards bodies go back and make incompatible changes. You can't do that with the web. It's more like biology. You preserve what still works. You don't want to break ATP metabolism or whatever. So you have to kind of resign yourself to the reality of worse is better being enshrined in actual design points you might not like. And that happened with JavaScript. And I'm way over it, but it also, I think, was a huge advantage. Which is why JavaScript has kind of swept a lot of programming domains. People will say, "Oh, it's not because of merit." Well, you're right, but we also improved it over time in the standards body. I spent 20 years doing that, and you don't get that choice. It's like, I'm not saying that was the best language. I'm just saying that was the right time to do it. And I like to say the alternative was not to do it. I could have told Netscape, "I can't do this. It's too rushed." And it would have been Visual Basic script, and it would have been bad.
So that's a good way to present the alternative. But so it was a Netscape, and you have written it in how many days, and why was it only that many days, and what was the goal and the underlying principles in your mind at the time?
So the whole I'm sort of describing worse is better in a frenetic way because it fit the model of Netscape. When it was known that Jim Clark and Mark Andreessen were founding Netscape, and they did the first release in 1994. That browser took over from Mosaic. In fact, that's why Mozilla is called that. It's the Mosaic killer. It's like the giant monster that kills Mosaic.
That's awesome.
And they knew they could, it wasn't that, again, it's not like you're doing advanced scientific research that is changing the world. You're more like taking down the last iteration on the browser marked it, which had images and, other affordances before you stopped working on it. And you're making Netscape the new thing that has images, plugins, which was the way to do video back in the day. It had something that's kind of died now for tiled windows called frames and frame sets. It had HTML tables. That was new. Eric Bina did tables in Netscape 1.1. So when I got there, they were heading toward IPO. Clark wanted to IPO early. I think his instinct was right. And that kicked off the whole .com era, right? There was a recession in the US in 91. You can see old Law and Order reruns where they talk about the recession, how hard it's hitting New Yorkers. And after that, Greenspan really goosed things at the Federal Reserve, and technology had been sort of fermenting in a way that came together with the internet. And Netscape made it, possible to do pets.com, to do eBay, to get people to recognize a URL on a billboard and then type it in when they get home. And that was huge. That was so fast moving a rocket that Mark and the engineering team there thought we need to make this a programmable browser, not just a document viewer, not just a video.
So it was all HTML with images and tables, and also, like you said, frames. And
Early
so
plugins.
There's no dynamic element at all.
Yeah, the most dynamism you get was from a plugin, which there were a few of them then. Flash didn't exist at that point. It was, I think...
Java applets yet, or no?
Well, that's the thing. We did the deal with Sun. In fact, I was recruited to go do Scheme in the browser. Remember Guy Steele and Gerald Sussman's beautiful Lisp variant. I was going to do it in the browser because my friends from SGI thought, hey, we like Scheme, you like Scheme. And I'm like, I hardly ever use Scheme. It's not really used in industry except in sort of silos. But I like it. Okay, I'll come do Scheme in the browser. I have a slide from my 2017 talk where I have Bruce Willis crawling through the duct in Die Hard. He's like, come out to the coast, have a lot of fun. Come on, do Scheme in the browser. But when I got there was no Scheme in the browser because they'd started a deal with Sun Microsystems. And my best contact there was Bill Joy, who I admired as a Berkeley Unix founder and Sun founder. And Bill got the idea of making the browser programmable too. And so the main idea was to put the Java VM, which at that point was not really easy to embed, into Netscape, including the Netscape version on Windows that was still most popular, which was the 16-bit Windows 3.1, which was going away. Microsoft was coming out with Windows 95, and everyone was afraid they were going to do, Internet Explorer, I guess, 2 at that point, 3 the next year. They already bought or invested in somehow Spyglass, this other company that shot out from NCSA at University of Illinois. And in fact, Microsoft had tried to buy Netscape in late 94 before I got there. And I heard about this later. I heard they offered way too little money. And so, Jim Barksdale and Jim Clark said, get out of here, pound sand. But then they realized, oh, this is going to hurt us because now they're going to copy us. It didn't happen right away. I'm not sure when Gates' Internet tidal wave memo was written. That's the famous memo he wrote when Bill Gates realized that Microsoft was going down this old copy AOL path or copy CompuServe path, a project called Blackbird, presumably after the SR-71, I don't know. But they were going to make a dial-up service with a custom content language stack and custom rendering. It wasn't the web. They could have content partners. They have a lot of money. But it still wasn't to scale the web. It wasn't going to be compelling. And Gates realized this, and he turned the company on a dime, and they couldn't buy Netscape. Again, I'm not sure of the timing, so they decided to copy it. And once we realized that, everybody inside Netscape felt even more urgency and more of a frenetic mood. And so my chance to do Scheme disappeared when the Java deal started brewing. But there was still a chance to do a companion language to Java because Java is a compiled language. It's evolved and improved quite a lot since then too, but it was for sort of serious advanced programmers that cost a certain salary or hourly rate. And people observed, Bill Joy observed, and Mark Andreessen and I observed that in a mature stack like Microsoft, you really benefit from having a scripting language like Visual Basic, which became Visual Basic Script in IE3, but didn't take over and kill JavaScript, that you need 2 languages. One is for the component writers who are higher price and more expert, and the other is for scripters, certified public accountants, designers, graphic designers with some programming inclination, anybody, amateurs, doesn't matter. There's a much more demotic approach there for programming the components together, gluing them together. Some people say duct tape language, which I don't really like. But we saw, Bill Joy and Mark Andreessen and I, we saw the need for a companion language. And the gleam in our eye was to call it JavaScript, though I didn't like it. That was marketing's plan. Mark called it Mocha, which I liked. And Netscape marketing, I think, didn't like that. So they said, oh, there's some trademark in some software somewhere that uses Mocha, so we can't use that. And they tried LiveScript in August, and that didn't last. And then finally, we got the trademark license in December 1995. But the work I did to prove that it could be done was important because I came in April, and even then Netscape was growing so fast that they couldn't find an open hiring requisition in the client team for me. So they hired me into the server team. And I worked for a month on the server team on what became HTTP 1.1. So I had done protocol work at Silicon Graphics with Greg Chesson, former Bell Labs grad student intern who knew all the Unix founders. And Greg was very interested in taking protocols to the next level with VLSI because he thought that CPUs wouldn't scale up. He was mistaken in that, unfortunately. Moore's law more than kept up, and you have gigabit Ethernet running with conventional processors. But I worked on protocols at SGI as well as Unix kernel hacking and NFS and things like that. So I came into Netscape to work on the server side for a month. But I was thinking the whole time, what should this language be like? Should it be easy to use? Might its syntax even be more like natural language, like Hyper Talk, which is Bill Atkinson's language, in HyperCard, if you've ever used HyperCard on an early Mac. And I thought, well, I'd like to do that, but my management is saying, make it look like Java, which looks like C from a distance.
What does that mean? Is it braces? We're talking about visually? Does it mean like what management? Do they understand what
they don't? Marketing didn't know, but management did. Like Rick Shell, the VP of engineering, knew. And we had a plan even that was, if you have this companion language, you're going to glue things together between Java and JavaScript. So you're going to have commerce in memory in the heap with data types. So you're going to want some of the data types in Java to reflect in the JavaScript. You're going to want the primitive types that Java unfortunately separated from objects. So at least some of them, double, let's call it in Java's terms, from the C term for double precision, floating point, or strings or Booleans, and objects. And so right away, there was this constraint that looking like Java meant kind of the C curly brace syntax, but also some of the data types and objects.
Like objects and so on, all that kind of stuff.
Dotted call,
comparison operator, all
garbage
that
collection, all that stuff.
Collection,
even the bitwise operators and the shift operators, including the unsigned right shift, which Java had because it didn't have unsigned integer types. It said if you want to do unsigned operations, use an operator. And that turned out to be important much later. I'll tell that story if I have time. But JavaScript inherited a set of operators, the expression grammar, the statement grammar up to a point from Java. But I wanted a functional language. I wanted scheme, a little bit of scheme, even though it wasn't as clean as scheme.
So you had a love, sorry to interrupt, you had a love for scheme and Lisp, that functional language landscape.
Yes, I wanted first-class functions because I saw the need for callbacks in the browser where it's a single-threaded program.
Wow.
All the early browsers were single-threaded, and it's the right model for users. Most users weren't ready for mutual exclusion and threading. So in a single-threaded world, you cannot block the user interface. So you have to use a callback and run later. And without getting too fancy and trying to capture the continuation like callcc does in Scheme, I thought, I'll just make it easy to have fun args, first-class functions you pass downward and they can be called back. And Java didn't have that at the time. It took forever to get proper first-class functions, lambdas now into Java 7 or 8, I think.
It did have concurrency, right?
Yes.
From the very beginning. But you were thinking that the JavaScript in the browser would not have the luxury of being concurrent.
That's right. And the reason was Java was going to run into plugins, so it could fork threads and go to town. But the main action in the browser was in a single-threaded program, a single Unix process on Unix or Windows. And it was where you had to service the event loop and then go, do things, respond to the network, lay out some HTML, render it, turn, widths into heights by filling containers, boxes, the early, what became the CSS box model, and run scripts to, make the thing livelier, respond to user input. And all that event-driven programming was in part like HyperCard because HyperCard had this on event name syntax. Mm-hmm. And so that's why you have in JavaScript on-click run together as the name of the event handler. And there's some funny ones, on mouse over and on mouse out. People still complain about those. But, there are many more events now over the years standardized. But it was a mix of event-driven single-threaded programming because it had to run in the main thread of the browser where the action is. And Java never got there, which meant Java could not interact easily or quickly or in a nested way with the document, with the objects reflected from the HTML document, with the tables and forms and so on. And that is one of the reasons I think JavaScript survived and Java kind of died. Java was in this plugin prison. It essentially was confined to a rectangle, the applet rectangle. And while we even built next year, Nick Thompson, a friend from SGI, who was an intern grad student at CMU at the time, built the first version of Live Connect to glue Java and JavaScript together to deliver on that vision where you do have commerce between the data types in the heap.
Did it work?
It worked, but Java was in charge. JavaScript was in charge, and Java was just these components, these helper objects.
You might as well do everything in JavaScript.
And what happened over time? It's like an evolutionary filter. It just kind of, who needs the plugin? And in fact, Sun mismanaged Java as a plugin. They thought, oh, Netscape was giving us the distribution vehicle, and we don't care about the browser. It's just about getting Java out there. And that was a big miscalculation. They then tried, because Microsoft was killing Netscape after a few years, they tried getting into Microsoft. And you may remember there was a Sun Microsoft deal, which famously blew up. And Microsoft kicked Java out of Windows. And that's when they really pulled the trigger. I think they'd already evaluated it and liked it on Anders Hellsberg's .NET and C#, and decided we're going to just not have Java. We don't want any of that Sun stuff. We don't want the patent risk. We don't want... I'm not sure what the fights were about. There was some patent angle to it, I think. And up till then, Microsoft had been using Java components, like in Outlook Web Access, which had a lot of JavaScript to be a webmail-like, Hotmail-like user interface. They had to call the mail server through HTTP, and they used a Java object to do this. And when they gave the boot to Sun, they suddenly the left hand gave the boot and the right hand said, we better do something else in Outlook Web Access. What are we going to do? And they said, let's just add an ActiveX component, which is their own native way of embedding things in languages. And we'll make it, it'll be what became XML HTTP request, which is now a web standard for calling asynchronously. And it's been replaced by the fetch API in HTML5 or HTML living document. But this whole lineage goes back to Java being successfully the loser and getting kicked out. And after Microsoft kicked it out, it was a plugin, and you would find it required for like smart card banking in the Nordic countries, where that was mandated by law, but really didn't get used much. Or, there were pilots who used it for flight information. But Flash, which Netscape could have bought, but fortunately didn't.
Fortunately didn't.
Yeah, we would have screwed it up. I mean,
what year are we talking about with Flash?
I think after the IPO, so it was probably late '95. And
Flash was around. Was it Adobe? No, it wasn't.
No, it was called Future Splash, and it was these brothers, Jonathan Gay, I think his name was. And he came knocking, and the marketing guy at Netscape, who was screening the technology partners or wannabe acquisitions, was brutal, and just everybody wanted to get in on the Netscape, stock gravy train, and he sent them packing, and they ended up selling to Macromedia, and Macromedia was where Flash was created. And the good thing about Macromedia was it was a tool company, so it invested in the best ideas, I think, which are still somewhat lost to us of Flash. The timeline. Animation is sort of an immutable function over time.
They had the tooling around that too, like that Dreamweaver. There's a Flash
Director. There were a bunch of them.
Yeah, I mean, yeah, that was a
Flash Builder was one of the last ones. These tools were used by real artists and special effects people and designers. All the restaurant websites around 2005 were done in Flash, which was, we were trying to do HTML5 at the same time. That was the Firefox era. We were trying to make the web capable enough you didn't need Flash. But if you recall, you go to a restaurant, it's like, this is kind of like a game or something. It's like a Flash. All the font looks small. And
so you didn't like Flash from the beginning. You're like, this doesn't feel right.
Not really. I actually admire Flash's technology, and I'm pretty pragmatic about these things. And I realized that, it doesn't matter if you're dealt a bad hand, like JavaScript was a rush job, or if you have Flash as a plugin and you can invest in the tools and make it pretty good. You should make it better for your users and grow it as best you can. And what happened with the browser due to Microsoft's monopoly abuse, for which they were convicted, and even after that, until I think Firefox and then Chrome, was people kept saying, "Oh, the web can't do X, it can't do Y. Yeah. We'll have to have a plugin. We'll have to have a new approach. We'll clean the slate and have a new web." And everyone who said that failed. And the reason they failed is because there's too much value in the web, this huge network. And the worse is better principle means that you can not only start bad, which they all sneer at, but get on first and get wide distribution, get sort of an evolutionary advantage in the priority of place, but you can also improve it over time.
Yes.
And so if you're going to improve Flash, and for some reason Flash is now out of favor, Steve Jobs said you can't have Flash on the iPhone. That was probably the death knell. Put your energy into JavaScript. And that happened, right? So we did things at Mozilla with Adobe to improve, which bought Macromedia, to improve Flash and to improve the version of JavaScript that was in Flash. We tried to standardize that.